Okay everyone, here we're going to go through the steps required to mark the diminish, to find the diminish for your jack rafter, and then mark those jack rafters on your guide rafter, your guide common rafter that you should already have done. So we're going to go through that here now, and of course this video assumes that you in this case, as is the case as most all roofs that hip roofs I've worked on, it's the same pitch on the ends as on the sides of the hip roof, and usually you'll know that by when you look at the plan view of a hip roof. If the hip line is drawn at 45 degrees, then that indicates that it is indeed the same pitch all around. So I just want to add that note in there with regards to what I'm alluding to there on the screen. So here you have your guide common rafter coming into screen here, and on this guide common, we, as I said earlier, we'll be marked all, as well as being a guide for all the common rafters, and you can see the plumb cuts already marked up there. That represents the center of the ridge board, and later on, of course, as this is a guide for the common, we'll have to take half the ridge off that, but we'll be taking our measurements from the center of the ridge board here. So there's a formula that will find out what is the difference from, we'll say, the longest jack to the second longest jack, and so forth and so on down as far as the wall plate. So that formula is going to come up here now on the screen, and it's a very handy formula actually. Basically it's as follows. If you use your rafter centers, which is typically in Ireland, we'll say, and most European countries will be 400 millimeters, and you divide by the cost of the pitch of the roof, and that will get you the difference between the various jack rafters going down to the roof. So starting with the longest to the second longest, that'll be your first diminish, and so forth and so on down through the roof. So here we're going to go through that now. So if you look carefully here, you'll see that's my tape I just sprung out there. I've measured down my jack diminish, and now I'm going to put a mark here. After having used the formula, I've discovered what the jack diminish is for this particular pitch of the roof, and you can see I've hooked my tape on the top corner in line with the plumb line that's already marked on the common guide rafter, or common pattern rafter, some people might refer to it. So here we're going to use the calculator on my Android phone, my Samsung phone. So we'll hit the calculator app here, which is the green app, and we'll then use the formula to get the jack diminish for our roof. And so we'll use the following formula. The following formula is as follows. You put in the rafter centers first, so it's typically would be 400 millimeters, so go 400 millimeters divided by, and now we have to go into scientific calculator mode for the rest of this exercise. So hit that square logo third over to the right from that clock up on top, 2/3 of the way up the screen. So that's that logo there. It brings you into scientific calculator, that square logo. I'm just after tapping, and when we're in scientific calculator, we have to then now hit the cost button. So hit cost, and we'll assume a pitch of 30 degrees for this roof, so just tap in 30. So there's the formula: rafter centers divided by cost of the roof pitch, and then after you've all done all that, hit the equals button, and there you go. That is the difference from the longest jack to the next longest jack all the way down the roof. When in my case, I'll be marking all these down on the guide rafter for the common rafter. So now we take our bevel, which is set to the plumb cut that's marked at the top of this pattern rafter. It's all it indicated, and just mark the line indicating red there. And so now we've the longest jack diminish mark, but this is only the geometrical version of it. And as you can see appeared in here, I'm now going to illustrate the difference between the line diagram version of the intersection between the hip rafter and the jack rafter. So you'll see a part plan view here. That's the center line of the jack rafter viewed on plan, and that's the center line of the hip rafter viewed on plan that this jack rafter is intersecting with. And right now this point and this point line up perfectly, because when you do a geometrical calculation, it just assumes all the components of the roof basically are lines. But as you'll see in this animation here, then things change when you add in the thicknesses of the various components of the roof, which you'll see appearing here now. So there's the jack rafter thickness appearing in there now, in the and here's your hip. So there you are. You can see, you know, at the moment geometrically everything is fine here, and on the side elevation view, everything looks all aligned here, and it correlates with the plan view. But the actual piece of the jack itself, the longest sharp point of the jack, is actually a little bit further down the rafter, should be down around here on the guide rafter, in other words. So when I play this animation here, it'll illustrate the point I'm trying to make actually. So here's the side view of the jack rafter here, and you'll see the first deduction to be done here really is you're going to have to get from here to here. So now at least you're touching the jack, you're on the edge, you're although albeit halfway in on the jack, you're now at the jack rafter, but we want to end up here, which correlates with this on the side elevation view here. So this first deduction here to here is actually termed half the diagonal of the hip rafter. Diagonal meaning a 45-degree line drawn across the hip rafter. So a full diagonal will go from there to there, of course, but this is only half the diagonal, so it's a 45-degree line drawn from there to there. Whatever that is, you can physically measure it on the edge of your hip rafter. Also, the other thing that will get you that distance is if you take the actual half thickness of the hip and multiply it by the square root of 2, it will always give you the 45-degree diagonal thickness in, because you're dealing with a right angle triangle there, 45-degree right angle triangle. But basically, just without complicating it too much, from here to here, the first deduction you have to make is half the diagonal of your hip rafter, and that gets you to this point here on the side of the rafter. So if I play this further on here, then you'll see the second alteration that has to be made. You've now arrived at this point here, so you'll have to come back towards the ridge to get to the longest point of the jack rafter. And here you are, there's the green line coming down here now, so you can see we're now on the longest point of the longest jack. This is where we want to be. So you can see the two steps we had to make first. So in other words, I suppose you could say that gap there is basically you offset your geometrical line that you drew first here in red by half the diagonal of the hip minus half the thickness of your jack, and that is that gap there actually. That's another way of putting it. But if you look at you have a visual here if you want to see the side elevation and how it correlates with the plan view of the same components of the same jack rafter. At least it'll help you visualize and maybe help you understand what has taken place here. And the thing is, once you get the longest point of the longest jack, you've know for the rest of the way down along the pattern rafter, when you're marking the rest of the jacks, you don't have to worry about any of these deductions anymore. You only have to do this at the longest jack. From here on down, it'll merely just to diminish, as will be illustrated here after a while. So we'll just continue on. So this is what's happening now. What had happened up here in the red arrow, this is the same thing happening here on the side elevation. You're coming back in half the diagonal of your hip rafter, and then you can draw a little bit of a plumb line there, which I've done in blue, and you're going to come back the direction you came from, half the thickness of the jack itself. And when you get onto the end of that point there, which is the tip of the blue arrow, you now are on the longest point of the longest jack. So if you draw a plumb line through that, yeah, that is the longest point now of your longest jack. And I put ingrained there just to illustrate it is the longest point. So you mark that as illustrated here, and you get your bevel as shown here and draw it. And now that is the longest point, as I've already stated, of your longest jack. So then after that, as I already stated, you just merely go down just the jack diminished that you got from the formula that we stated earlier on in this presentation. So no need to worry about deductions or anything else from here on down as far as the other end of this pattern rafter, this guide rafter for the commons, which will now also have the jack rafters marked in them as well. So, and that's illustrated here. You just mark it and just bring your bevel up and draw the plumb cut, which is also the jack side cut as well, same as the plumb cut for the common rafter. And I just put in this just to illustrate it in a light wooden colour here. That is your second longest jack there then. So there's another visual there just to give you an idea of where you're at. And now that you've got your jack diminish here, you just take that distance and just keep stepping it, as I stated already, all the way down the rafter the rest of the way. And that's all your jacks then marked. And all these jacks will have the same tail as the common rafter. So you know, you could just put a cut the top edge of the jack as shown here when you get your timber on site. Put the jack edge cut on it with your skill saw. Your skill saw will be tilted at 45 degrees, and you'd run your skill saw on this line, and should give you that edge cut. And then you just place it on the guide rafter and just mark the tail that's on the guide rafter, and that's also the tail of your jack. So that's all. There's the other end of this jack rafter is the exact same, as I've already stated, as the tail of the common rafter. So just just a quick note here for those of you who might in the future or currently might be doing roof in other countries such as the USA, where the pitch in degrees is not given on site or usually on the plans of a house. So in that case, you'd have to determine the pitch in degrees if you're using that formula I used earlier on in this presentation. So this note here that's that I've added here, I've given you already. For instance, in the United States, if it's termed a 312 roof, that means for every 12 inches of run, it's rising 3. So I've already used the formula, and here is the pitch for that particular roof. Basically, this up here illustrates what it is you have to do to find out what is, if you are roofing in the US, say for instance if it's a 6 roof, you take the rise per foot divided by 12 as stated here, and whatever answer you get on your calculator, there's the shift button is on that calculator. Hit the shift button, hit 10, simply hit equals, and that is the pitch in degrees of that roof in the US, as it were, or any other countries that would have a similar system. But as I said, I've already done it here for you. I've used the formulas and popped in the various conversions here for you guys.